Over the years, I have rendered a lot of cinematics out of Unreal Engine, and that's why today I'm going to show you my entire rendering workflow so that you too can render cinematics out of Unreal Engine. Today's episode is sponsored by Fox Render Farm. Welcome to Virtual Production Insider. I'm your host, David Stapp, and today we are diving deep into rendering in Unreal Engine, and we're going to look at quite a bit of stuff because, as I mentioned in the intro, I've been doing this for a long time. I've run into a lot of different kind of issues and quirks, and I've developed a few workarounds here and there, so I just want to dive deep into my process and how I tackle certain challenges when it comes to rendering. And by the end of this, you should have a good understanding of how rendering works in Unreal Engine and how to get your images, how to get your animations out of Unreal Engine and into something like an editing program like Adobe Premiere Pro, DaVinci Resolve, or CapCut. And I'm going to show you how to render those animations out of Unreal using 3 different methods. And for this tutorial today, we are going to be using Unreal Engine 5.5, but the majority of this tutorial will apply to any version of Unreal Engine 5. Now, I want to give a really quick disclaimer before we go forward, and that is there is no magic bullet when it comes to rendering in Unreal Engine 5. I have noticed over the years, it doesn't matter what settings I use, what preset I create, what console variable I use, every time I go to render a cinematic, it is a different experience. There is a different issue I run into, there's a different setting I have to enable. It's always some little thing that I have to kind of troubleshoot. So the reason I bring this up is so that you can understand that rendering in Unreal Engine 5 is a trial and error process sometimes. Now, there will be some times when you can just use a preset or use some default settings and it'll work fine. But as you get into more complex setups, as you start to use things like metahumans or really advanced levels and blueprints, you're gonna find that there are things that you have to go and troubleshoot, things you have to tweak or adjust or enable to get the render to work correctly, to look correctly as it did in the editor, and to, not crash. All right, so we're in Unreal Engine now, and I've pulled up one of my previous projects. This is the project I created for the How to Previs episode here on the channel, and we've just got this really basic kind of opening shot that we're going to use for rendering and kind of configuring all of our settings. So first things first, what we need to do is make sure that we've got a few plugins enabled. So come up here to Edit, go to Plugins, and let's type in Movie Render Queue. This is kind of the main method we're going to be using today. We're going to show you a couple other methods too, but this is a plugin you want to make sure is enabled. And if it's not, you're going to need to check that and click Restart Now. One other plugin I want you to make sure is enabled is the Apple ProRes Media plugin. Now, I'm going to be in the minority here maybe, but we're going to talk about some file output types and why I like to use Apple ProRes as opposed to something like PNG and EXR. So go ahead, if you want to use Apple ProRes for exporting out of video, you're going to need to check that here as well. So if you've had to check anything here for plugins, go ahead and hit Restart Now and then come back into your editor. Now, like I just said, I like to use Apple ProRes when I'm exporting my cinematics out of Unreal Engine. This might be a little contested. People might disagree with this, and that's fine. But, there are kind of 3 main file types that you're going to be exporting out of Unreal Engine typically, right? And those 3 are either PNG, EXR, or Apple ProRes in my case. And you're going to see next to each option, it displays the bit depth for the color output for that codec. So you'll notice that PNG is only 8-bit, EXR is 16-bit, and ProRes is 10 to 12-bit depending on which flavor of ProRes you choose. So here's a really simplified explanation of what all this means. You've got 8-bit color, 10-bit color, 12-bit color. Those are some of the most common bit depths you're going to encounter. And the more bit depth you have, the more iterations of colors, the more literal colors you have available to you so that you actually have smoother transitions between colors. Imagine you have a gradient. Well, if you're in 8-bit color, you might see literal steps where it actually causes what's called banding. You're seeing this really odd artifacting in it, and that's because there's just not enough color information there to make this smooth gradient. The higher the bit depth in color, the more color you have available, and the lower your chances of running into something like banding where there's these weird artifacts as it's transitioning between colors. Now, I definitely don't think that 8-bit color is enough, and that's why I typically stay away from PNG, but I'm going to tell you right now, EXR being 16-bit, that's a lot, and honestly, EXR file size is another thing to consider. EXR is massive. If you're going for the highest quality possible, EXR is going to be the best option, but just know that it's going to come at a cost of just massive file size. For example, I rendered one shot in a video recently in an EXR sequence, and I also rendered it in an Apple ProRes video file. And the EXR sequence ended up being about 10 gigs in size, and the ProRes version was only about a little over 100 megabytes in size. That is a dramatic difference. And especially if you're on a larger project, that's something to consider. If you're having to render, hundreds of shots, if you're working on very large projects, that's going to eat up a lot of space. And that's something to consider when it comes to, file storage. And you'll notice if you choose ProRes as your option, you get different flavors available to you. And you'll see if I choose a different one, pay attention right here. It says 12-bit right now. That's because we're on the highest flavor of it. But if we drop down to 422 proxy, it's now 10-bit, which is still good. I'm typically sticking with something like Apple ProRes 422, not even HQ. I found that 422 is kind of this nice middle ground for quality and file size. So again, this is just my preference. You can use EXR if you'd like. I wouldn't really recommend using PNG just because it is 8-bit color depth. But if you don't want to use ProRes, then EXR is definitely the way to go. All right, so that's a quick overview of plugins and file output types. So now let's look at how to actually set up a sequence and how to start rendering. Once you've got your scene set up, you need to come up to this clapboard right here and you need to add a new level sequence. I usually create a cinematics folder, and then you can name it whatever you want for that sequence you're creating. And so once you put in the name here, you just hit save, and that's going to create your sequence. Now I've already created a sequence, and you'll notice if I hit the clapboard again, I've got my previs sequence right here that I can just open right up. So once you create that, you're going to see a sequence pop up that looks like a video editing sequence. Now I've already covered in previous tutorials how to actually animate in Sequencer and how to set up cameras, so we're not really going to go over that. But the main thing we're looking for right here is the render movie options. You see you've got a clapboard right here, but before we click on that, you'll see if you click those three dots, you have two options right here. And we're going to start by looking at the legacy renderer today, because I still find this useful. This is the old rendering method that came from like Unreal Engine 4, I believe, and then it got replaced by Movie Render Queue, but the legacy renderer still can be handy and can still be useful, especially when you're rendering some of your really early test renders. So I'm going to switch to the legacy renderer, and then I'm going to click the clapboard here, and that's going to bring up this dialog window. This is a very kind of simplified window, but it really can help you get some quick images out of Unreal just to see how things are looking. And this is something that's really important in the cinematics process. I've heard the phrase test early and test often, and really we could say render early and render often. The reason I recommend this is so that you can kind of see, okay, are things working like I'm seeing them in the editor? Because sometimes when you render something out, it doesn't look right. Things maybe are missing, things are looking like they're offline or got moved around. So it's a good idea to do a quick render every now and then as you're creating your scene, just to kind of see, okay, is everything looking correct? Does something need to be fixed? Because then you can get ahead of that early on. And this is why I like to use the legacy renderer as opposed to the Movie Render Queue, because it's just quicker to get an image or video out of Unreal Engine. You can see we've got some really basic options up here, and the first one is how you want to render it out. Do you want to render it as EXR, PNG, or like we just enabled, Apple ProRes? And now you can see we get access to those flavors of ProRes. And I said I stick with just 422, and so then you also have access to resolution. It has a really handy drop down with different resolutions such as 720, 1080, or Ultra HD 2160. If you're trying to do like a custom aspect ratio like 239, this is where you could put in a custom resolution. And then the last thing you want to do is determine where you want to save it. Click those three dots, and then you can choose a folder of where you want to save your video. And one final thing I like to look at is if you wanted to add any kind of warm-up frames, you can do that right down here at the bottom. This is handy, especially if you're using things like Niagara particle systems or things that need to actually warm up in the engine. This is where you can add some frames to help make sure that they're already animating whenever the render starts. What you can do is add something like 24 frames or 48 frames. Obviously 24 frames equals 1 second according to how we set our frame rate for our sequence. So basically that will determine how many seconds of warm up you want to add. And then once you've got that all configured, all you gotta do is hit capture movie and it will render it out for you. And boom, you just rendered out your first cinematic very quickly. And this is, in my opinion, the fastest way to get a image or video out of Unreal Engine. And I think this is the perfect way to get those early test renders out. All right, so that's the legacy renderer. So now if we go back to our three dots here, we switch back over to Movie Render Queue. We can now click the clapboard. All right, so when you bring a sequence into Movie Render Queue, these are kind of the default settings you're going to see here. We have a config and we have the output, but this output really is going to be determined by the config. So the main place you're going to go into is the settings into this config. And we're going to open it right up. up, and these are the default settings. We have a JPEG sequence, we have the deferred rendering, and we have the output. Now we've already covered the export method. I'm going to highlight JPEG, I'm going to delete that out, and you can choose your preferred output method. And in this case, that's going to be Apple ProRes, and we're going to switch that to Apple ProRes 422, where we get 10-bit color, and we're finding that nice balance of file size and quality. Next up is deferred rendering, and one note here, this is where you change whether you are rendering out the normal way with something like Lumen, or if you want to use path tracing. Because if you want to use path tracing, you actually need to delete deferred rendering out, and then you need to add path tracer, and that will take its place under rendering. So now you can see we have path tracer set up, and then you'll just need to make sure that your path tracer settings are configured in the post-process volume, and then you'll be ready to render. But in this case, we're not going to be using path tracing. We're just going to go back to good old deferred rendering. And one quick bonus tip here before we move on, if you're wanting to export something like a depth pass or a motion vector, you can do that inside of Unreal Engine 5.5 by default. If you come under deferred rendering and you go under deferred rendered data, click this little arrow to drop that down, and then go under each of these arrows, and you'll see there's a movie render queue world depth, and there's movie render queue motion vectors, and you can actually enable both of these. Now, this is information that can be used in a program like Nuke. Let's say you're wanting to add depth of field externally, like you don't want to render out of Unreal Engine with depth of field. You want to add it in something like Nuke. You can enable the world depth. You're going to get a depth pass that can be used in Nuke, and you can add the depth of field after the fact. This also applies to motion vectors. If you're wanting to add motion blur externally, and you want to use something like the Real Smart Motion Blur plugin, well, that plugin can use motion vector data, and you could add motion blur later on. But one thing to be aware of is that these data passes will not work with ProRes. You have to use EXR, because EXR supports embedding data like a depth pass or motion vector. So you'll just want to be sure to delete out ProRes. You want to add EXR, and then you want to check multi-layer, and that will ensure that the data will be embedded into the EXR file. That way you don't have to have multiple files. It's all just a part of that one EXR sequence. All right, so I switched back to Apple ProRes, and now we're going to go over the output options. And this is going to look similar to the legacy renderer. This is where we put in things like our resolution. So in this case, we can put in 3840 by 2160. The frame rate, again, is going to be determined by the sequencer, but you can override that. And up at the top, this is where you choose where to save that animation and how it will name it. So those are the default settings for the movie render queue. So now let's get into the things that you can add to really spice up your animations. The first one, and it's probably one of the most important ones, is adding anti-aliasing. So come up to settings, anti-aliasing, and this is going to help with the actual motion in your animation and getting rid of any kind of jagged edges on your geometry in the scene. Now, typically when you're rendering out your animations, you've got motion blur, and so that's why we really just need to be adding to the temporal sample count. And this is another section of the video where people might disagree. You might have your own preference. And again, this is all trial and error, guys. You got to find what you like and what works best for you. So I have found that doing a spatial sample count of 1 and a temporal sample count of 24 works really well, especially when you've got a lot of motion in your animation, because the more temporal samples you have, the smoother the motion is going to be on your character when they're, swinging their arm or doing whatever kind of animation. Now, next we do need to check override anti-aliasing, and now you have the option to use a different anti-aliasing method, and I have really liked using the temporal super resolution method, but you're going to notice we get this error message down here, and basically to fix this, we basically need to tell the engine how many temporal samples to use. So come down here to your console command, type in r.temporal AA samples, and then type in however many samples we plan on doing. I'm going to type in 24, hit enter, and then if we just hit the checkbox and then check it again, you'll see that error message has gone away. So now we've basically told the engine how many temporal samples we're going to use, and now you can use temporal super resolution for your anti-aliasing method. Now, I like to render my warm-up frames, and I'm going to check that box right here, and this is where we can tell it, again, how many warm-up frames we want to do. So keeping in mind, if you have something like simulations like Niagara, or if you even have media playback in your scene, adding warm-up frames can ensure that they don't start in a turned off state whenever you start the render. And again, this is going to be seasoned to taste. I've found that something like 48 frames for both the render warm-up count and engine warm-up count gets you pretty good results. That's 2 seconds of warm up. But sometimes if you're working with a really large landscape and lots of foliage, like a big forest environment, and you're working with procedural foliage spawning, I have found that you actually have to bump up the warm up count by a lot, like something like 500 frames or even 1,000 frames sometimes. And by doing this, this ensures that all of the foliage populates in the scene. So again, anti-aliasing is one of those things that's going to change on a project to project basis. You might be be able to get away with less temporal samples if there's not a lot of motion in your scene, and you might be able to get away with less warm-up frames if you're working with a simple scene. So keep that in mind. You know, the more complex it is, you might need to bump up your temporal sample count, you might need to bump up your warm-up frames, things like that. The next thing we're going to add is console variables, and you can find that right here in the top under settings. And this is one of the areas of rendering where it is very easy to buy into the idea that if I have more console variables, the better my image is going to be when it gets exported out. I have found this to not be true. I've found my list of console variables over the years just shrinking more and more and more. I used to use like over 30 console variables at one point, and now it's like way less because I've found that there's kind of diminishing returns with a lot of these console variables. Sometimes they'll increase your render time, but get you very little in return of quality, right? So here's a list of console variables that I've kind of whittled down over the years that I find to actually make a difference in the image quality of your export. Now, one of the most commonly used ones is screen percentage, and I just put this in here to show you that this actually determines how it's rendering, you know, what resolution. If you were to set it to 100, it's just going to render at its default resolution. If you were to bump it up to like 150, it's now going to multiply your resolution by 1.5 times and then downsample that back to this selected resolution. So if we render at 1080 and we want to do a 150% screen percentage, well, now it's going to render it at 1620, but then it's going to downsample it. It's going to resize it back down to a 1080p resolution. And this can technically get you some extra detail on a very kind of small level, but this is one of those console variables that really will up your export time pretty exponentially. It will also tax your hardware, your GPU, much more than most console variables, because now it's having to render extra pixels. It's rendering at a higher resolution. And this is something extremely important to consider if you're exporting at Ultra HD, because once you start to go beyond 4K in terms of rendering pixels, this gets really heavy on your system. These days, I'm just keeping screen percentage at 100 because I am exporting at 4K, and that's giving me plenty of detail. Now, next up, we've got R.motion blur quality and R.motion blur separable. Basically, this is determining the quality of our motion blur and how many passes of motion blur it should do to get us a smoother result. Now, another bonus tip in this video is you can actually highlight these console variables, and it will literally give you an explanation of what that console variable does and its default settings and other settings it can be set to. So take, for example, right here, defines the motion blur method, which allows to adjust for quality or performance. And then below that definition, we can choose between 0 and 4 for the quality of our motion blur. And you can see I've got it set to 4 because if you highlight this again, 3 is the default. So we've actually bumped it up to be the highest quality possible for our motion blur. And that's what these boxes are on the right side here. This is where you're putting in the value of how you want to adjust that console command. The next one I like to use is depth of field quality, R.depth of field quality. And you can see we have set that to a value of 4 by default. This is set to 2. So we are actually bumping up the quality of our depth of field quite a bit. This does take longer, obviously, to render, but you're going to get a better result, especially in the bokeh in the background. Then we have R.upscale.quality. This defines the quality in which screen percentage and windowed full screen scales the 3D rendering. By default, this is set to 3. We've now bumped it up to 5 to really get the most out of our upsampling. Next up, we have R.force.LOD, and this really is only helpful if you're using a scene that has objects that use level of detail. If you've got a scene that uses nothing but nanite, then this really doesn't apply because nanite does not use level of detail. But this console command basically forces everything in the scene to render at LOD 0, which is the highest quality. Then we've got temporal AA samples. This is what we just did a second ago. We basically told the engine how many temporal samples we're working with, and in this case is 24. And I've actually added an extra console variable here at the bottom just so I can remove it. And I did this so I can show you how important it is to keep an eye on those descriptions whenever you highlight over a console variable, because I've seen a lot of videos over the years that go over different render settings, different console variables, and I've noticed them adding console variables that aren't really necessary because all they're doing is just telling it to render in its default state. And here's a great example. I've seen this one pop up before where it's r.raytracing.culling and people set it to 0, but if you highlight it, you can see that 0 is actually the default setting and we don't really need to do anything here. We don't need to add this. So this is really really one of the big reasons why my list of console variables has really, decreased over the years. And I also encourage you to try rendering without console variables. If you're working with a really simple scene, these might not be necessary, and ultimately they might just be increasing your render time instead of adding quality. But again, this is a list of console variables that I like to use, and you are welcome to use them as well. And now you're ready to export out a movie render queue. These are the main settings that I use. And what you can do now that you've configured all this once, you can now save this as a preset and bring it over to other projects that you work in. And to do this, all you got to do is come up here, hit save as a preset. We can name this whatever we'd like, and we'll just call this MRQ preset, and we'll hit save. And so now that we've got everything set up, we're now ready to render, and we can hit the render local option here. And you can see it's rendering our warm-up frames, and it'll start going frame by frame and applying our anti-alias settings, which is represented by the sub sample count. You can see it's going 1 through 24 on every frame. And now you just sit back and relax until it's finished, and you can then bring it into your editing program. So that's our second render method, but what about the third render method? Well, that actually brings us to today's sponsor, which is Fox Render Farm. Fox Render Farm is a web-based render platform where you can upload your project from really any 3D application to be rendered in the cloud. This includes programs like Maya, Houdini, and even Unreal Engine. This has been especially helpful for me, and if you want to go try it out for yourself, Fox Render Farm has a great installation and setup guide that walks you through the whole process of how to upload your Unreal Engine project file and then rendering out your sequence that you can then download once it's finished. So be sure to check out Fox Render Farm if you're a 3D artist who's looking to gain access to even higher-end equipment and computer hardware, or if you're looking to offload your renders so that you can continue working on your local machine. So that's it for today, guys. Thank you so much for checking out the episode. And as a reminder, I am currently working on my Unreal Engine Film School course. This is a course dedicated to literally creating cinematics in Unreal Engine, but most importantly, it's all about incorporating real-world filmmaking techniques, real-world camera techniques, real-world lighting techniques to really elevate and take your cinematics to the next level. And we do have a wait list that you can sign up for using a Google form link in the description below. So be sure to sign up for that if you want to be notified about pricing and when the course will be releasing. And if you haven't already, be sure to join our Discord server. This is a place where you can surround yourself with other people in the virtual production community. And be sure to like this video if you found anything of value. If you have any questions, be sure to leave me a comment down below. And as always, I'm David Stapp with Virtual Production Insider, and we'll see you guys next time.